Hello, my name is Shanmugasundar Ramesh. I'm going to explain about my research thesis about ADAS, Enhancing Secure Communication Protocol in ADAS System, that is Advanced Driving Assistance System. So nowadays we know that the car has become driving has become very simple. Nowadays there is no need for human interaction for driving the car. So this ADAS system drives the car automatically by mixing up data of the sensors like camera, XGPS, and etc. So, for example, what if these data gets compromised or data gets mishandled by a hacker, to which would lead to major accidents and major disadvantages. So, to avoid this, I come up with a new encryption concept which involves MIDM, AES, GCM encryption with the combination of blockchain. We use Ethereum blockchain. So MIDM, what is MIDM? Multi-input data management. As we have different type of sensors, so we need to combine all these sensor data into one single line and encrypt the data. So this multi-input data management is used to do that. So when the data gets combined into a single line, it goes through AES GCM. It goes through AES GCM. So these AES uses 256-bit encryption. AES GCM uses 256-bit encryption where the data becomes into a ciphertext. The single line data gets converted into a ciphertext. When the ciphertext is then pushed into the Ethereum blockchain, where the data gets stored, and whenever the data needs to be retrieved, the data gets retrieved, and if the data is valid, it will accept the data and decrypt it. If the data is valid, it will decline the data. So this is the entire block diagram of the implementation. So we receive as I told you before, we receive the data from IoT from the client side, which in the encrypted form, which is MIDM, AES, GCM. Then it goes to the blockchain network where the data gets stored and where the data gets stored. When the data gets comes back to the ADAS system, it gets verified. Then if the data is verified, if it is yes, it gets decrypted and command gets executed in ADAS system. So what we have done is to show the proof of work. We have created a web application since we were not able to do it in an ADAS system. We have created a web application where the sensor data is stored. This where the sensor data is stored. This web application is coded in React.js, and we use three types of platforms. That is Ganache. Ganache is used to test blockchain concepts of Ethereum. MetaMask is the bridge between the Ganache and the Chrome browser and the web application. So and one more thing is Solidity. The programming language Solidity here helps to deploy smart contracts, which is one of the most important concept in this implementation. Smart concept that so as told you, smart contracts are one of the most important feature in this implementation because they are the ones that feed the data into the blockchain. So now we are going to deploy the application. The web application runs in port 3000. So we use Yarn, which is a library management, a Java script library management. This is the web application that is developed to test the proof of concept. So this is how the ADAS system would look containing all the data for the sensor. For example, we'll have the data for speed, acceleration, engine temperature, vehicle location, battery remaining, next charging station, tire pressure, and next service. So we see. So we have to show the proof of concept. we have two buttons, that is encrypt and decrypt. But in the real system, we wouldn't have encrypt decrypt. The data would automatically get encrypted and they automatically get decrypted. So when we press encrypt, the entire data, all the data gets combined into a single line using MIDM, and then it gets encrypted using AES GCM algorithm, where the data, this is the ciphertext. So as soon as we click encrypt, this after the data gets encrypted, the we see this pop-up. This pop-up is called the MetaMask. MetaMask is the bridge between the Chrome extension, the Chrome and the blockchain. So blockchain is in Ganesha platform. So this is the bridge between those two. So to push the data, we are paying through Ethereum, that is the gas price. So when we push the data, we pay this gas price to confirm that the data is going into the Ganache platform, that is the Ethereum blockchain. So we give a confirmation here. We see transaction confirm, and we go to the Ganache platform, and we see that the data is being stored at 77 in this block number 28. So before that, I forgot to explain that this is a crypto wallet where it contains the public address and the private key. So we feed this private key to create a bridge between the blockchain and the Chrome. We feed the private key into MetaMask so that we pay the gas price and take in the data. So now we go to the blocks and see the block has been created. So when we press decrypt, so for the decryption part, it's very easy. So when we press decrypt, the data gets fetched from the blockchain and gets, see, the cipher gets fetched from the blockchain, and it decrypts using AES-GCM algorithm, and then using MIDM again, it splits the data and sends the data to respective sensors. So this is the implementation. This is the protocol which a secure communication protocol which I've developed for an ADAS system. So seeing to the code, so this is where the data gets fetched and the data gets encrypted. Uh, and the decryption also takes place here. And the data, at last, the data gets split into different levels, speed, acceleration, impedance, and temperature, and it gets fed into the system. So, coming to the future work and conclusion, this study proposed the innovative and comprehensive approach to enhance ADAS secure communication. Blockchain technology for secure proof of authentication, AES-GSEM for dynamic adaptive data encryption, and MIDM for intelligent data synthesis are groundbreaking approach to the complex challenges of dynamic and sensitive data in autonomous driving environment. These technologies work together to create an all-encompassing ADAS security framework that ensures the authenticity, security, and integrity of communication activities that are essential to an autonomous car safety and efficiency. Further research refinement of proposed security architecture are possible. In particular, real-world testing and validation of updated secure communication protocol in ADAS system are essential. Testing and integrating the proposed approaches into operational autonomous automobile will reveal the system's performance, efficiency, and various scenarios. To adapt to self-driving technology, future research should test and improve security architecture. The security model may be improved by studying cryptographic advances, specifically blockchain consensus techniques and adaptive encryption parameters, investigating the use of artificial intelligence and machine learning for anomaly detection in secure communication protocol may increase the system's resistance to new threats. The advancing IDA secure communication future research can ensure autonomous driving safety and security in changing technological environment. So this is all about my research thesis. Thank you.